Hi, ladies and gentlemen. This is Mr. Main just coming at you with a video for this afternoon. What we're doing this afternoon is we're going to be taking a look at slides number 9 through 15. Yes, 15. So let's take a look at what this activity is going to ask us to do. So if we look down at slide number 10, let's take a look at the directions for this piece. So it says connecting equations to graphs, part number 1. So it says we saw equations in different forms representing the same constant. For example, x plus 4y is equal to 18 or 28. We used this equation yesterday when we were looking at, well, actually 2 days ago when we were looking, was it today? It was today. So it was yesterday for you during your afternoon work. And we also had this equation of y equals 1/4 x plus 7. These both represented the number of games and rides that a student could do with a fixed budget. What information about the situation and about the graphs can we gain from a standard form ax plus by equals c? So we were looking at this piece right here yesterday. So we had these two equations. This was the original equation that we were given for that third one from the afternoon work yesterday. Then we converted it to this, so this was in standard form. Then we converted it to our y-intercept form, where we had to first subtract x from each side, then divide each term, not the whole side, each term by 4 to get that y isolated. So then when we did that, we're trying to think about now, what information does the situation give you when it's in standard form? So what does it give you when it's in standard form? It allows you to sort of have two separate variables that you can solve for a total number, right? So for example, yesterday we were talking about, in the morning, we were talking about those people that were they were paving, right? So they were paving roads, and they were hiring new people to get a total budget of $1 million. So when you have two variables that you're going to be adding together to get something, that is going to be a good time for you to use this standard form equation. So what information does the y-intercept form give us? So what's also nice about this standard form is that we can plug 0 in for your two variables. So we can plug 0 in for x, get your y-intercept. You can plug 0 in for your y and get your x-intercept, which is pretty cool. So that's another really cool way that you can graph using these standard form equations. Graphing with these is a little bit challenging, but what's nice about it is you can plug zeros in for each of these variables and get your different y-intercepts so that you can create a graph for yourself. What information does the slope-intercept form give us? So the slope-intercept form gives us exactly what it tells us, the slope of our graph. So it talks about the direction and the rise and the run. It also gives us that y-intercept, where it hits our y-axis, which are two which you can use to plot new points. You plot your first point at your y-intercept, then you go up your rise and run of your slope. What might be an efficient way to graph an equation in the form of ax plus by equals c, so standard form? How is it efficient to graph these things? Like I just said, you're going to find your two intercepts, and then you connect them to create your graph, your equation line, okay? So now let's take a look at what this activity is going to be asking us to do. Our learning targets for today are: I can take an equation of the form ax plus by equals c and rearrange it into the equivalent form of y equals mx plus b to find the slope and the vertical intercept. Basically, what we're doing is we're doing that thing we've been doing for the last week. We're isolating for a different variable. Before we solved for a constant, so that's like a whole number, well, not necessarily a whole number, a number that doesn't have a variable attached. Now we're isolating, moving these things around, doing these things to this equation to get it so that the y is now isolated. And when we do that, we get it to our y-intercept form, where we can find our slope and our y-intercept. Pretty cool. So the activity for today is we are matching each of the equations with the slope m and the y-intercept of its graph. So let me tell you what that means. You are taking these 5 equations right here, and you have to convert them to slope-intercept form, or solve them, isolate them for y. These are just like that last one where all of these, we're going to have to do some division because all of our y's have constant or values attached to them. They're not just a regular y. So we are going to do one of them together, and then you're going to take 15 working minutes to do the other 4. Maybe not 15 working minutes. It depends how long the video gets to be. Okay. So I'm going to pull up my document camera, and we're going to do this first one together. So I'm going to write it down first so that I have it on my paper. Negative 4y, or 4x plus 3y equals 3. So now let's take a look at how we go on and isolate this guy for our y value, right? So y equals slope-intercept form. So what I'm going to do is I'm going to call up ImageMate here. I'm going to make it full screen. I'm going to place this now down on the floor, and I'm going to move this under my camera here. I'm going to turn on my light for myself. Oh, no, that's definitely too bright. Never mind. I'm going to zoom it in, and let's take a look, okay? So what we're doing here is we have this negative 4x plus 3y equals 3. So we need to get this y to be isolated. So the first thing that we're going to do to each side is we're going to... Oh, you were right. No way. That's crazy. We're going to add 4x to each side because I need to get this x over to the other side. So first I'm going to add 4x to each side. My suggestion to you is that you are going to do all 5 of these on your own piece of paper so that you can have your work for later on because you're going to have to insert a picture on the next slide. Okay, so when you do that, these cancel out. We're left with 3y is equal to 3 plus 4x. Okay, so now I need to isolate or get this y by itself. So how do you isolate? This is attached through multiplication. Let me just grab a different color because I don't know why I'm going to do that. So where it's attached through multiplication, how do you undo that multiplication? You undo that multiplication by dividing by 3, but you're not going to divide this whole side by 3. You're going to divide each term or piece by 3. Okay, so when we do that, because this 3 is divisible by 3, so we're going to actually divide it out. So we're going to divide by 3, divide by 3. When I do that, I'm left with just my y is equal to 3 divided by 3. I can simplify to a 1, and then I'm going to add, and this is a fraction of 4/3, 4/3 x. Okay, so if I'm looking at this equation here, my slope is my number that's attached to my variable. My slope is what number? You are right, 4/3. My y-intercept, which is my number that's my constant all by itself, is a positive 1. So now I need to look back and I need to match this with one of those sets of descriptions on that slideshow. So what I'm going to do is I'm going to pull my computer back up here. I'm going to minimize. I'm going to minimize that, and I'm going to say to myself, I have a slope of 4/3 and a y-intercept of 1. So if I look at this right here, we have a slope of 4/3. That's these two right here. I have a y-intercept of 0, 1 or 0, -2. We said our slope, our intercept was a positive 1. So this one, number 1, equation number 1, would match with letter B. Okay, so your job right now, if you're listening, listen close. You are going to take for yourself, you're going to take I'm going to give you 12 working minutes to simplify each of these equations here, isolating for your y. Then you're going to match them with the description here, or your slopes and your y-intercepts, and we're going to come back and we're going to compare in 9 minutes. Or I'm going to give you 10. I'm going to give you 10 minutes. So I'm going to give you 10 minutes of work time. I'm going to start my timer. I'm going to let it sit. I'm going to let it run. And you are going to work on these 4. I'm telling you right now, please make sure that you're doing it on a separate piece of paper because on the next slide, you need to insert pictures of your work. So you're taking 10 minutes starting now. Awesome. We have another 8 minutes and 51 seconds for ourselves. Wonderful. We're down to 7:57. Might be a good idea, just like we did before, to write down what your slope and your y-intercept is, so that when you go to look at the list, it's easy peasy lemon squeezy. Wonderful job. We're at 7:21. I got a chance on my shoulder. Gonna let it go. Awesome. We're down to 6:22. Awesome, we're down to 4 minutes and 30. If you finish early, you can start to take a look at, actually you can start to insert pictures of your work from this activity onto slide number 13. I'm actually going to insert another one just so that you have 2 spots, so you can do A, B, C, and then D, E. And 1, 2, 3, 4, 5. Okay, we have 3 more working minutes, my friends. Awesome job. Okay, you're at 2 minutes. Okay, we're at 1:15. 1:15. Okay, we're now at 35 more working seconds. Then we're going to come back together and go through these. It's going to be a nice shorter video today because we're almost done. Okay, we're at 15. 15 more working seconds, guys. Start to make your way back to the video if you haven't already. 3, 2, 1, go. Okay, let's make our way back to our screen if we haven't already. I am going to switch over to my my ImageMate, my document camera, and let's take a look at this guy. So if we look at number 2, we have 12x plus minus 4y is equal to 8. So first, I need to isolate to get this y by itself. So the first thing I need to do is I need to move this variable that has nothing to do with the y. So I'm going to move this 12y. And this is a positive 12y, so I'm going to subtract 12x from each side. And I'm going to be left with negative 4y is equal to 8 minus 12x. Okay? And I need to isolate or get this 4y by this negative 4y just to be a y. So that means this is attached through multiplication. The way that we undo this is by dividing by, you need to remember to keep that sign, negative 4. Divide each term or piece by negative 4. Negative 4, negative 4. We're left with a y on my left side. 8 divided by negative 4 is a negative 2. Negative 12x divided by negative 4. 12 divided by 4 is a positive 3x. So in this case, my slope is a positive 3. My y-intercept is a negative 2. Okay? I'm going to compare these guys to the list afterwards. So I'm going to solve them all first, isolate them first, and then I'm going to go back after. So if we look at number 3 now, I have 8x plus 2y is equal to 16. I need to move my x's first by subtracting 8x from each side. I'm left with 2y equals 16 minus 8x. Okay, my next move, I need to isolate this x here. This is attached through multiplication. So the way that I undo that multiplication is by dividing by 2. We need to divide each term by 2. Each term, divide by 2, divide by 2. I'm left with a y is equal to 16 divided by 2 is 8. Negative 8 divided by 2 is a negative 4x. Okay, so my slope is negative 4x, or negative 4. Mr. Main is a goofball, negative 4. My y-intercept, let me bring this up a little bit. My y-intercept, this number by itself, this constant, is an 8. Okay? So here we go. Remembering that you're pausing if you need to remember these things or get these things written down, get them corrected. Okay. So I have a negative. I need to move this x first over to the other side. The opposite of minus 8 or negative 8 is a positive, or x is a positive x. A positive x. 1/3 y is equal to 1/3 plus x. Okay, so now we need to isolate and get this y by itself. So we need to, since there's a fraction here, we need to multiply by the reciprocal. Yes, multiply by 3/1. Multiply each term by 3. So I multiply my times 3 times 3. Okay, so I cancel out and I'm left with my y is equal to 1/3 times 3. Do we know that? 1/3 times 3/1 equals 3/3, which is equal to 1. So it is a 1 plus 3 times x is a 3x. Okay? My slope is, the number that's attached to my x is a 3. My y-intercept is a positive 1. Boom. Here we go. Last one. Here we go. Now we're here. This guy's not too bad. I'm telling you. I promise. So we have, we need to move this x over to the other side. And the way that we move this x is by doing the opposite. This is a negative 4x, so we add 4x. We want to add 4 because we're not going to divide by 4 because we want to keep this whole thing together. So we're going to add 4x to the left and to the right side. We're going to be left with a 3y is equal to negative 6 plus 4x. So now, to isolate my y here, I need to divide my left by 3, and then divide each term by 3. divide by 3, divide by 3. Y is equal to negative 2. 6 divided by 3 is negative 2, plus 4 over 3, 4/3 x. Let's identify our slope in our y-intercept. Our slope is a 4/3. Our y-intercept is a negative 2. Okay, let's come back and let's make this decision here. So if we compare these guys that we got here, let me just grab my computer, sorry guys. So if we just look at number 5, so we got our number 5, we said our slope was 4/3 and our y-intercept was negative 2. Slope of 4/3, y-intercept of negative 2. So 5 goes with letter C. Okay, so now we're looking at, no, okay, never mind. We are looking at, let's say, equation number 2. So let me grab my paper. Equation number 2, we said we had a slope of 3 and a y-intercept of negative 2. So a slope of 3 and a y-intercept of negative 2. Number 2 matches with letter E. Okay, now let's look at 3. We said we had a slope of 4, negative 4, and a y-intercept of 8. A slope of negative 4, a y-intercept of 8. So that was letter D. Okay, now 4, we said had a slope of 3 and a y-intercept of 1. A slope of 3, a y-intercept of 1, letter A. Those are our matches there. If you need to go back and see how we did it, go back, and I did them all out on paper for us. So what you need to do on 13 and 14 now, if you didn't do it already, you need to take nice pictures of your work. That means get it with your phone or use your camera and take a picture. Make sure it's clear. Make sure I can read it, okay? So that's 13 and 14. I gave you enough space for both of them there. And then on 15, how are we ending this today? 15, and then on 16 there will be a link to a review, but I'm going to talk about that I talk about in the class already. So how would you describe the match process for the strategy? Was it fairly efficient or laborious? Was it prone to error? So what did we do? Before we even started to make matches, we solved all of them. We isolated all of them. So we isolated all of them. And then made choices. I don't think that we did the wrong way of doing it. I think we did the best way of doing it because we didn't just guess. We were strategic in the way that we did it, and we made we isolated for different variables. Nice job. So if the list of slopes and y-intercepts are not available for you to choose from, would you still be able to determine the slope and the y-intercept? Oh my God. So guys, I'm sorry. I don't know why I just got so excited, but I did. How did I tell you that we could do this before? We can take standard form equations and we can graph them. We can plug 0 in for both of them, get each one of your intercepts. You could have found all this information without converting it. You could have found your 2 intercepts and actually graphed them. So we could have calculated our intercepts. And I'm going to put in parentheses our y and x, and then plotted them and connected. Okay? And would you still use graphs to make matches if the graphing needed to be done by hand? So would you want to graph these guys, or would you want to just sort of do this out, convert it? I personally think that I like the converting. I think you have to be strategic though, because sometimes when you have like fractions here, like it might be better just to take this equation here and plug 0 in for each of them and solve it and see what happens. And then get your 2 intercepts and then connect them. So I don't think there's really like a set way that you should do it. I think that you have to just be strategic when you're looking at this equation. Like this guy here, I know that these numbers are all divisible by 4. So I think that solving or isolating for your y would be easier than graphing them, because if you're solving, I think you're like 1 divided by 12, sometimes it gets a little bit hinky. So listen, you can use both ways of plugging 0 in for each, finding your y-intercepts, and then plotting them and connecting them, or you can convert them to a y-intercept form. It really is just a strategic move based on what you think that, which way is going to be easier for you. I think I like the isolating, but that's just me. So ladies and gentlemen, we were able to be really specific this time and convert. Oh my goodness, guys, we just converted from standard form to y-intercept form. Let me tell you how hard this was for my kids last year. Very hard. So I'm very proud of you guys. I'm sorry, I know I went a little bit long, but you're completely done. Oh my goodness, look at that. You need to look at I want you to take a look at the review this weekend. Don't spend too much time on it, but I want you to take a look at it. And I will see you all on Monday. Please be safe, have fun, and reach out if you guys have any questions. Awesome job today, guys. I'm so proud. Okay, actually, here we go. One thing, our code word for today is, one second. Oh my goodness, Mr. Rain. Baby shark. Dun, 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 baby shark. Dun, 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 dun. Okay, now really have a good weekend. Okay, bye guys.